Yeah, so I'm Dimitris. So I got interested into benchmarking ZKVMs in RIM. And so basically the project is about using state transition functions and benchmarking various ZKVMs. And the goal is to iterate through this process to identify possible roadblocks in the RIM code base, which are going, fix them and just move on. And also during this process, I should keep in mind that this should be compatible with the bin chain. So far, like there are two ZKVMs that have been implemented by the team. There are some things that have to be fixed, but mostly it's done. One is risk 0, and the other one is SP1. And the plan is to extend the benchmarking to other ZKVMs like OpenVM, ZISC, Zolt. So, by the way, there will be no, the RIM client will be a bin client, consensus client, and currently they also have some beacon implementation, but it will be just for testing. So, my current understanding of the thing is that, there will be some code that will have to be proved, which goes under the guest directory, and the proving is happening in the host. And the way it works is that there is some input sent by the host to the guest, then there is some computation being carried out, and then the guest commits the output back to the host, and then the host is doing the proving and the validation, and then creates a receipt. So the implementation that I've looked in, so how does this happen? So in the host directory, we create this executor environment, so you cannot read it. So this environment gives access to guests in order to read the input that they need. And then they will perform the computation and commit the output to, so the terminology is journal, which is the public part of the output. And then the receipt that will be created is an attestation of with a valid execution of the guest program. And then the last step is the actual proving, which is done in host. So the prover is set up, the proving is happening, and also verification is being published. So in this particular problem, there are still a few things that are missing in the implementation. One is the process execution payload. I discussed a little bit with Unawit, who proposed the project. The problem here is that you have to call the execution payload from an execution client, and this would somehow spoil the proof. I didn't manage to I don't know if this is a priority if they want to actually resolve this, or they are going to leave it blank for the moment. What seems to be a priority is some optimizations that have not happened. And also, currently, the way that this example works is that each field of the block body is tested one at a time. So you cannot run a proof for the whole block body. And this is also something that has to be implemented in this project. On the logistics is that Unamut is actually working on this. So he says that he's going to finish in 4 or 5 months. So either one of the fellows or me are going to collaborate in the sense that we are going to split the load, or this is going to be dealt entirely by him, and the rest of us will work on some other ZKVM from scratch. And so the first step that I think would be very useful for all of us would be to actually scan the whole space of ZKVMs and create some kind of matrix with some comparisons about the accessibility of the code base and all that, so that we reach an informed decision on which one to implement. And another thing which I found important is collaboration, because there have been a lot of people stating that they want to work on it. So we have to somehow communicate and distribute the tasks so there is no overlap. From the RIM team, what they consider more valuable is that we work on a different ZKVM implementation, because this would be very useful for them. And then there is a possible, one problem that we also discussed is the following. in case something happens on the side of the ZKVM, there will be no help because maybe people will not be familiar with the code base. So this is something to keep in mind. And yeah, the last thing is that there is a pretty similar project proposed by Gandine. I'm willing to switch if a lot of people want to work on this, and there are fewer people on the other side, so that we can balance things out. Yeah, I think yeah, I'm done.
Morning, everyone. I'm Prototype. So this is my, I would say, the project is from the RIM team. So this is one of their four projects. The RIM Beacon API. The mentors will be Kobe, Caden, and Unawa. So what is RIM? RIM is a Beam chain client written in Rust. And its goal is to be modular, contributor-friendly, blazing fast. So currently, I think it's the most popular Beam client at the moment. Although the Beam chain doesn't have a spec at the moment, there are like a lot of contributors, a lot of I think participants from this cohort. They tend to contribute to RIM. They have like more than 38 contributors already, and maybe 6 people already working in the team. So what is Beam chain? Because RIM is a Beam chain client. So in short, Beam chain is like the next generation of consensus layer of Ethereum. So I think when Justin Drake announced it last year at DEF CON, he mentioned like 9 main features fall into like 3 categories. But I think a lot of the features can come even before Beam. So I think the core features would be these 4 features: faster slot, 4-second slots, and 3 slots finality, and chain snarkification, and post-quantum signatures. So that's it. So actually, they're doing speccing at the moment. It won't be ready until maybe this time next year. So what is RIM team actually working on at the moment? Because there's no spec to implement. So at the moment, they focus on 3 things. So actually, I think they're the only team, the Beam client team, trying to implement a full-featured beacon chain client at the moment. It's like 70-80% done, and they're building based on the consensus spec. I think the reason I asked them why they're doing it, the reason is like because in DEF CON, Justin mentioned like he wanted to be like a hard fork instead of a separate chain, had to merge back. So maybe we need to get this client running before the hard fork, and it syncs with the current beacon chain. Then a certain slot is switched to like a hop switch to the beam chain. That's one possibility, but needs to be discussed. So I think that's one reason. The other one is trying to build talent to find recruit new developers, to attract new developers to this project, and developers need something to work on to get familiar with Ethereum. So I think that's just the second reason. Yeah. Also, they mentioned that through really implementing the beacon chain features, they can do some experiments within the ZKVM to try to run the current one to find bottlenecks. That's the learning process. So the second key focus of the project is experiments with ZKVMs. Dimitris already mentioned. That the third reason is like talent building, already mentioned. So what I aim to help, there were like 60 people on the team at the moment. I think 2 people from this cohort, they already working on the validator client, so that's enough people. And besides the ZKVM work, there are other 2 tasks, Beacon API and P2P. So what I aim for is I want to help on Beacon API implementations. At the moment there are 70 GitHub issues tagged with Beacon API. Actually, 42 of them already closed because there are a lot of people they want to help. Like Ring is quite popular, and there are 28 open, 19 unassigned. I tend to start from the unassigned ones. Some of them are quite hard because I check the Beacon API. It's like actually some of the API endpoint has a lot of implementation details. It's not covered in the consensus spec or so I had to like also reference other Beacon chain clients to see what they're doing. Yeah, there might be some missing ones not listed as issue. I would go through one by one, maybe add this ones also. I think that's the plan for me. But because there are so many contributors, a lot of people may come and pick up the issues they finish. So like the whole issues might be finished early before this cohort ends. So if I have time for or there's no issues for me to work on, I'll explore the P2P side, and also I'll tend to learn ZKVM through working with the Ring team, and also interested in post-quantum cryptography. So on the P2P layer, through the Beam Day from yesterday, I felt like because a lot of fundamental change, the post-quantum signature change, the signature size will be different, the aggregation communication will be different. Also because the shorter slot time and the 3 slot finality, I think that there will be a lot of more communications within peers. So I think there will be a lot of work on the P2P side of things. So maybe I think if we finish the Beacon API, I'll try to dig in on this area. That's all. You can ask me questions. Probably I cannot answer at the moment, but I mark it down. I'll try to answer it in the future.
Any questions, comments? Yeah, I'm wondering, like, implementing peer-to-peer Beacon API, like it's already written in Rust in Lighthouse, in Grandine, right? So how is it different in Ream, or like why does it need to be fully implemented when we already have 2 Rust implementations? Or maybe like what is the architectural difference there? Like what are you aiming for?
So I think I just started looking into the code base of Lighthouse. One thing I think I hadn't spent enough time to go through the code base. But I tried to like jump from functions to functions just to see how the stack works, how it flows. One of the feelings is like I would say like current Ring clients, Beacon implementation is easier to read. Like in Lighthouse, they use like generics heavily. Like when I try to read the code, like I get lost because it's a generic type onto another generic type. Like if I want to really find what's inside this type, like it's quite hard.
Yeah.
That's only. I think that's the only thing I felt at the moment, but I think I will find more things.
Okay, yes.
Yeah. But about the necessity, I can't say. Maybe it's not must have. But yeah, I think that's the starting point for me.
Yeah, awesome. Yeah, anything else? Anyone? Okay, thank you.
About the event translation, or as it was usually called in project proposals, Ergon RISC-V executable proof sourcing by Markov. I haven't talked to Markov, so if anything here I'm saying is wrong or bad, it's my own fault. Yeah. So I have quickly just who am I, just so you have a sense of who you're talking to. I'm this guy on Discord, I'm the bird. And I like both Bitcoin and Ethereum. I also like playing CTFs and fuzzing, and also do some machine learning research. And I love the EVM, which is like partial reason I chose this project. And the reason I wanted to join this cohort was to do a bit more applied research. And so the direction I wanted to go in was either securing, so I originally had a project idea of doing differential fuzzing between the clients. But it seems like I might go more the scaling route, which was also some of another direction I want to work on, like scaling the frame layer 1. So why do this? So some of you have probably seen this post already by Vitalik on ETH Magicians, where he says, oh, maybe we should just swap up the instruction set architecture of the EVM and move to RISC-V. And the reason for that is that the EVM instruction set is kind of hard to prove, or it's not necessarily hard to prove, it's just inefficient to prove. So we want to potentially swap the instruction set to make it easier for CKVMs to prove stuff. So should we replace the entire EVM with RISC-V? Like just a few months ago we were talking about EOF, and like that never happened. Then like we had the EWASM in the past, and like maybe we can do this. Maybe we can just like transpile it so that we can evaluate this approach and like see how the tooling and stuff like that actually works with RISC-V. So like translation isn't anything new. Like there are a lot of various projects done here. Like even Paradigm had this REVMC, which does something similar, where it takes EVM bytecode, turns it into LLVM IR, and then into native assembly. Yours truly has also written like EVM bytecode to Venom IR transpiler. So there's like a lot of projects that you can take inspiration from here. So how do we might do this? So as you might be able to see by my beautiful diagram, we kind of want to have a new module on the side. We want to like preserve the existing safe flow of the EVM, but we want to have like a bridge over to a transpilation component that like outsources the CKVM proving. Yep, separate module. So we probably want to add some execution hooks to like handle the generation of the ELF file used by the CKVM. And the transpilation component will be responsible for doing the EVM to RISC-V instruction set mapping, handle the fact that EVM uses 256-bit, but RISC-V probably uses 64-bit registers. Probably want to have constants in the read-only data section and precompiles. Probably want to use the external column. Yeah, maybe some Pruby-specific stuff also. So yeah, the road ahead. So I'm pretty ignorant to a lot of CKVM specifics. I didn't know much about this jumping into it, so still learning about that. But the good side of this project is that I kind of also don't need to know that much. I'm kind of like, that's kind of outsourced, but I also want to learn, because else I'm kind of like, I don't want to be ignorant to this stuff. But this project is also kind of big, so also as mentioned in the original project proposal, simplifications are allowed, so we are actually able to make a POC. And then we can remove the simplifications afterwards if we get a POC out. So like state can be provided like constants, with handling precompiles can be done more simplistically and stuff like that. And there are also some unknowns, like is RISC-V even the best CKVM or instructions? Which CKVM do we even want to use? And also is RISC-V even the best instruction set architecture for this? Like there might be a new CKVM tomorrow using MIPS or something. But yeah, the main goal of this project is basically just looking at the feasibility of all of this and like evaluating if this is even an approach worth doing. So yeah, thank you. And yeah, I posted this in Discord. I know that someone on the original stand-up call said they were going to work on this, but they didn't answer my message. So this is like a call out to whoever. I didn't get your name, but I know someone said on the stand-up call they wanted to work on this. So yeah, do reach out if you want to chat. Yeah, that's basically it.
Okay, yeah, thank
it seems like you will spend some time building the compiler, or especially for transpile
Yeah.
to RISC-V.
Mhm.
So do you have any plan for referencing any existing compiler like LLVM or something?
Well, I haven't most likely we're gonna have to leverage, or like the honest answer is that I haven't looked at it, so I don't really have an answer, but like it makes sense to like leverage some compiler that can take some IR and then output RISC-V. So yeah, using LLVM seems like a reasonable component to include, yeah.
Any other thoughts, comments, questions?
Not a question to you directly, but since you're working on this,
Mhm.
ever since that instruction set change proposal, the discussion that has started, so it has been argued, and from what I know, RISC-V-A is not the best for ZK VMs in
Right.
itself.
Yep.
B, it is a bit of, not a bit of, it's a totally overkill.
Yep.
For what the EVM does right now and what RISC-V provides. So
Yep.
any thoughts on that?
I mean, like I spent a lot of time last week like reading of all the reasons not to use RISC-V. So, or like why, like there was also a lot of comments on like Vitalik's original post, like why should we not use RISC-V? But I'm also in a believer that you should just do stuff and like see if it works or not. And like even if RISC-V turns out to be bad, if we are solving this using IR, we can always like swap out the actual underlying architecture. So I'm not totally locked to RISC-V. I view this as like writing a transpilation component, which should be modular enough that we can swap out with any architecture or any CKVM. Yeah.
No, it's great for experimentation. I'd love to follow.
Yeah.
Any
Yeah. Awesome. Anything else? Yeah.
Yeah. If not, find the bird on Discord. And,
Thank you.
Hi, I'm Jun, and I'm from South Korea. I'd like to present the project suggested by Prism team, which is the SSD query language and the Markov proof themes. So here's a quick, brief introduction myself. I'm still an undergraduate studying computer science at KAIST in Korea. And last semester was very cool. I built my own compiler and OS in Rust and C respectively. It was really cool. And also contributing to RIM for 6 months. And prior to the EPF, I have some experience in software engineering. So one of my notable work is build desktop applications for running a full validator node built on the Electron.js. And also I had some experience in open source contributions, including the Prism, REST, and Lighthouse. Okay. So here's the content, and let's get into it. The project introduction. I'd like to introduce the SSC, but I'm quite sure that all of you guys are familiar with this concept, so I just want to point out that SSC is a not self-describing scheme, so which means we requires a schema for deserializations, the SSC included bytes. So it's it's mostly not a problem in CL because consensus client all has their own knowledge for the what object they pass each other, so it's not mostly a problem. So you can find the SSC.dev, which is a very great starting point for this learning testing. So these are the projects, and those are 2 projects, but the Bastian from Prism suggested me to look up the both projects because they are quite entangled with each other. So I'd like to introduce both. The first one is SSDQL, which query the arbitrary SSD objects. So it may include some features like filtering range or something, but I would like to build a most basic query at first. And it was suggested by Ethan, and yeah, shout out to Ethan. And yeah, I've talked to Ethan yesterday about why do we need this. So I brought the reason for why do we need this. So it's for current users, we have some very ad hoc implementations for Beacon API. So especially for the accessing the fields, like for Electra, we have pending deposits, or consolidations, and we have all like sync committees. We have to access through a single API, which is very verbose. And also there are some APIs for the other clients, like debug APIs. So, for example, in Nimbus, we have the sync commit historical summaries. We have to fetch historical summaries from the its own implementation, which is very, I think, verbose. Also, for the future use case, there are SSC is the core building blocks for building the Ethereum in the future, including Beam or EL. So I guess it will help a lot to make our life easier. And also, the second thing is Merkle proof. So the term arbitrary is very important in this context because we can generate proofs for any field in the Merkle tree. And it seems like quite helpful for context of the ZKVM because we have to verify the untrusted input from the host program. So I think that will be great. And this is current status of the SSC, especially in Prism. Prism uses fast SSC, which is the Go implementations of the SSC, and mostly use the code generation, auto code generations. But I found an issue that they will migrate their own implementations called methodical SSC. So it will be planned. And also they are maintaining the encoding SSC package in their Prism repository, which is useful for the most of encoding. For the status of the projects, the SSC query language is, there's lots of things to discuss because we don't have spec, we don't have a design documents, very detailed things. So there's lots of things to discuss, but as I mentioned before, there's a great starting point, just parsing a path to the specific field. So it will be a great starting point. And second one is the GMP, the Merkle proofs. There are some ad hoc implementations for 3 fields for the light clients, but I can think that there are I worked on some draft VR for the generating Merkle proofs for the arbitrary fields that can be directly accessed from the eco state. So that's the current status. And roadmap, as I said, the two projects can be pipelined. So yeah, there's a lot, that can be entangled. And also I'm happy to discuss and collaborate about this topic because it's quite large. And also one thing I'd like to note is we can keep building because all the features can be tested locally with unit tests. So here's some roadmaps. I'd like to point out 2 things that I can start with parsing paths for the SSC query language, and also for the Merkle proofs. I should calculate the generalized index of the SSC tree for generating the proofs. So there's a roadmap, so you can refer to my slide after this talk. So that's the conclusion. I hope to spec this feature out after the EPF. So it will be nice for implementing any other clients in CL. So I'd like to design a good query language for this. So this is my just optimistic future for this feature. So yeah, and I'd like to also think about what is the good design for a query language in terms of the users or the developers. So I'd like to dig into this more. And I'd like to introduce 2 mentors, Radek and Bastian from Prism, and I think Radek is here, yeah. And also special shout out to Ethan for for advising the design of the SSC query language. So yeah, here's my Telegram and GitHub, so you can follow. I'm happy to chat, discuss. Thank you.
Any comments, questions, any thoughts? I'm wondering about one little thing that like you mentioned about also proving the SSZ in ZK. Like we can have the SSZ proof, but rely on Merkle, which is hashes. and hashes and zero knowledge are quite hard to prove. So
Yes.
does it work? Is there any implementation of this? Like, is it because it sounds very inefficient? Like, especially if SSE is supposed to be forward-looking, beam, and so on. Like,
Yeah, yeah.
Whether yeah.
In my knowledge, for the most common hash function is SHA-256, and there's some accelerating precompilers for the SHA-256. So it's super efficient if we use the precompilers. So it's I think the special designed circuit for the ZKVM calculating hash function will be feasible for your point.
Okay.
Yeah.
I also talked to Kev from EF recently, and he said that the CK stuff has improved to a level where SHA is only like 6 times slower than Poseidon now.
Only 6 times slower.
Yeah, and
Okay.
there are fewer hashes because smaller validators.
Okay.
It may be a valuable option.
Yeah.
Okay. Fair enough.
Like there is also an EIP to half the number of SHA hashes eventually.
Mm-hmm. Okay. Okay. Cool. Cool. Yeah. Thank you, Ethan. Thank you, John.
Thank you.
Yeah. That's it.
Thank you.
Awesome.
I'm still in the project selection. I still don't know which one I'm going to do, but this one is one that I think is going to be useful from the very beginning, because I know that there are some projects that would use the solution. And the project is called Prism Merkle Group of Everything. The scope of this project is clearly stated in the project proposal description, and is to generate a Merkle proof of arbitrary data. So for this project, we will try to create a Merkle proof of the blocks, the stakes, or any other objects or fields. The current state in Prism is that for the beacon state, we only generate a Merkle proof of the finalized checkpoints and of the current sync committee and the next sync committee. And this is due to the use of this proof. These proofs are, I guess they are used because for the checkpoint syncing, and also for the light clients which connect to the sync committee and need to verify the proof. But there are new use cases incoming in the area of staking pools, for example, where when in this first case is the withdrawal credential verification, when a validator is created by operators that when the validators keys are created by operators that you cannot trust, you need to make two deposit transactions to create the validators. The first one, you do one Ether transaction in which the withdrawal credentials are set, and after that, when the deposit transaction is processed by the consensus layer, there is a need to generate the Merkle proofs and verify that those withdrawal credentials are the withdrawal credentials expected, the ones that belongs to the staking pool, not the ones that the operator wants. That would be a front-running, what is called a front-running attack, a withdrawal credential front-running attack. There is also a solution from Nimbus, the verifying web designer, in which Nimbus provide the fee recipient proofs in order to detect if anybody is stealing the MEV. So for this, another use case, it would be interesting to have this proof. And also, it would be interesting to have aggregated data, in the sense that in the EVM, the SHA-256 is a costly it's a costly instruction, so you have to pay like 2,000 gas units for every hash, and for this proof you have to hash a lot. If you want to go from the validator to the validator's root, you have to do at least 43 hashes. and also you have to go to the beacon state and to the beacon block route. So if we can do, if we can aggregate a Merkle proof doing multi-proofs, or even go a bit far beyond the scope of this project and aggregate data based on the status of validators, for example, and sum the balances in order to report the TVL of the project in the consensus layer or the performance of the validator, it would be great. But for that, we would need zero knowledge. We could use zero knowledge algorithm or the ZKVMs. And so for this project, I think it is the methodology is very straightforward. We need to allow people to choose the anchors, and we also need to allow them to choose the fields and that they want to verify. After that, we will compute in a generic way the generalized indexes. After that, compute the path and build the Merkle tree with recurrent hashing. And in relation to this project, I have two goals. The first one, it would be to create the recent production ready code, create the generic Merkle proof and multi-proof, and also I see myself as more in the research side, so I would love to learn about the CK Foundation and make a prototype of proving of aggregated data proving, like the ones I said before, the TVL of a protocol or in the consensus layer, or the performance or something like that. And that is my presentation.
So, thank you, Ando. And do you have any thoughts, any questions? Anyone?
There is this EIP 7916, which can also help reduce the hash count, because like a lot of these lists, they have capacities that are far larger than than are actually reachable. And with 7916, the tree that kind of dynamically will grow, with just what's needed instead of having these 4D layer trees.
Yeah, it doesn't make sense.
Yeah, so maybe if that one gets more traction, it could also help you.
Yeah. Okay.
Okay. Well, yeah, thank you so much, Ando. And
I'm Sato, and the project I'm going to work on is called differential LLMing. This was suggested by Frederick from the security team. Okay, so the motivation behind the project. So basically, what happens during an implementation of EIP? So there are several client teams that have their own ways of implementing, and they make their own design decisions. And what might happen with time is that there might be potential attack vectors during the way the EIPs are implemented. There can be edge cases which needs to be figured out. There can be accidental deviation from the original EIP specs, or there can be suboptimal design choices. So the idea is, what if we have an automated system which can compare the various Ethereum client implementations of an EIP? So imagine as a user, which may be a core developer, you give input as the EIP number and the clients which you want to compare, and then in the output you get a report which compares the various EIP implementations. So for example, if you want to compare how EIP 4844 is implemented by Geth and Nethermind, so you can basically give that as an input and ideally get a report as an output, which compares them as well as looks at them from a security standpoint. So the key features of this system can be the following way. So at the heart of it will there be an agent, an AI agent, for example, AutoGen AI agent, which is created by Microsoft. So what an agent can do is essentially plan, act, and summarize. So one of the key issues with LLMs is the fact that the context length is limited. So the
top AI models or the LLMs can have maybe 100K, there are up to maybe 1 million these days, but no matter what, it will always be limited. So the idea is to have an AI agent that can plan through it. So it focuses on one particular aspect of an EIP, then it checks how it is implemented in a particular client, and then it maybe writes down the final report as a note. And then it moves on to the next part of the EIP, and so on. So it's essentially a loop through which it slowly and steadily knows or understands how a particular part of an EIP or several parts of EIPs are implemented in a client, and then it finally produces a report based on that. So at the heart of it is this AI agent, and to that agent, the idea is we provide him with several knowledge bases. So first of all, the knowledge base can be of the EIP itself. So basically EIP doc, the specs and the tests. So these constitute the EIP related knowledge base. There are other two relevant knowledge bases. So one of them is the client code itself. So imagine going through client code. So that is another knowledge base. And the third thing is the pull requests, which actually implement a particular EIP. So 3 types of knowledge bases. And the idea is to arrange these knowledge bases in such a way that those can be exposed via something called MCP servers, which stand for Model Context Protocol servers. So what it is about is essentially allowing an AI agent or even an LLM with tools through which it can get whatever knowledge base or functionality it wants, so that we will let the agent decide what it wants rather than us hard coding things. So the knowledge base, the agent, these are 2 important aspects. And then we have an orchestrator, which is based on top of Fast API to create an API. And this orchestrator will also manage the AutoGen agent. So I'm using AutoGen as a placeholder. There are several other AI agents as well, Creo AI, for example. So it will remain to be seen which one works best. And yeah, of course, finally there will be a front end for the user or a core developer to actually give input, and that front end can call the orchestrator. So that's the overall idea of the components. So this is representation of the overall architecture I mentioned. So there is the browser, which is the front end. There's an orchestrator, which based on top of Fast API and also manages the AutoGen agent. And then we are equipping the AutoGen agent with various MCPs. So the MCP can be related to, one of the MCPs can be the EIP knowledge base, the other one can be related to tests. That can be, I'm calling it graph knowledge base, which is based on top of the EIP ontology project. So that is a project which essentially creates a file which has which is useful for vector storages, and that file contains the knowledge of several EIPs as well as the keywords relevant to Ethereum or the EIP ecosystem in general. So with those knowledge base, as well as I'm calling it Git MCP servers. So those are relevant to the actual client code base. So for example, Get client code base or Nethermind client code base. So all these MCP servers are essentially the agent is aware of all these MCP servers, and then we give an agent a particular task. For example, like compare the implementation of this particular EIP across these and these clients. So then the agent will start a loop, and through that loop, it will slowly and steadily move across the various subcomponents of EIPs and find out how those are implemented. So that's the overall idea. And these knowledge base is stored in a graph storage. So for example, here I'm using this PG vector, which can store several knowledge base across in the form of a vector storage. But this is also a placeholder, so there are various others like Qtrand or Pinecone, and also there are other ways to do similarity search, which the MCP servers can use to give valuable information to the agent. So this is a rough example workflow. This is like a starting point. This may change with time. So let's say imagine you are initially giving the input in the browser, and the browser calls the orchestrator, And then there will be like the knowledge fetching session, for example, the knowledge of the list of pull requests using a Git MCP server, and the knowledge lookup for the particular EIP, for instance, let's say EIP 4844. So once the relevant knowledge is gotten by the AI agent, then the agent can start its own loop. So the loop essentially consists of the following. So the agent can plan, then act, and then take notes based on what it has thought. So for example, one small example of the planning and acting is the following. So it can, let's say, search blob gas price. So it wants to know how the blob gas price is implemented through EIP 4844, let's say in Go Ethereum. So then it is the action. Then it uses the Git MCP server to find the relevant chunks of code which might be actually doing that implementation. And then it finally, that might be several code chunks which do that. So it will go step by step across all of them, and finally write its own small note which summarizes how the blob gas price is implemented. And then it will move on to the next portion of the EIP. And finally, it will aggregate all of these to produce one single comparison report. And for, let's say, 2 clients, there will be 2 comparison reports, and then it will do the final comparison between the clients. So that's the overall idea here, but this is like, the current idea. It can change with time as I get more feedback from the actual code developers. So yeah, a little bit more about the orchestrator and the agent. So the orchestrator is based on top of Fast API. This provides the public API and manages the MCP tool containers, and it also manages the AutoGen AI agent. And this agent can be initialized through a prompt which can look similar to this. So the prompt can say, you are an EIP implementation analyst. Always plan, act, and note. So basically, hard coding what are the ways it is supposed to do the loop. And then we also need to ask it to only use the listed tools, which are the list of MCP servers. And then stop when you can finally produce the final report. So this is just an example of the system prompt which can be given to the AI agent. And then the loop ensures that every step is small, relatively small, so that we don't hit the context length limit of a particular LLM. And then come the knowledge bases. So the EIP knowledge base, the test knowledge base, as well as the graph KB MCP, which is relevant to the ontology project I mentioned before. So it essentially fetches the information from the EIP repos, the spec tests, as well as the ontology, and it chunks them and stores the embedding in a vector database. And then it exposes certain MCP server methods. Some examples can be the graph query or the knowledge base lookup for the EIP, or the test fetch, which is to fetch from the tests. And we'll let the agent decide what sort of functionality it needs to call for which portion of the sub EIP implementation. And then comes the Git MCP server. So this, I'm calling it Git MCP server as a placeholder name. So this implements, this covers the knowledge base of the repository itself. So let's say Go Ethereum client, we have to have knowledge about the full repository, as well as the corresponding pull requests which have implemented this particular EIP. So when it comes to the pull request itself, so GitHub has this GraphQL API through which we can pull the relevant pull requests. Then those can be embedded, and that can be a cosine similarity search which you can do to find out how relevant is that particular pull request to our current EIP. So there might be several pull requests which might not be that relevant to our use case. So, and maybe let's say if this is a very big EIP, then it might have taken maybe 50 or 100 pull requests to actually implement it. So maybe we can do like a cosine similarity search to maybe find out top 10 pull requests which are interesting for us, and then expose that knowledge through an MCP server. So that is for the pull requests. And regarding the full repository itself, we can chunk the full repository into smaller chunks and eventually convert them into embeddings and store in a vectorized database. and which can be exposed through an MCP server. So some example methods can be, one method can be relevant to the repo itself, the other method can be the git diff, the other can be the PR list, or another can be like a particular vector search. So this is still a work in progress. I have to narrow down the exact details. So yeah, the next steps include more research and actually finalizing the approach. I got some very good feedback from the Nimbus guys, so shout out to them. I will continue this approach of actually building it and as well as the same time getting feedback from actual code developers to have better idea about what kind of functionality they might actually be needed. And yeah, I'll eventually write a full proposal and roadmap in the coming 1 or 2 weeks, and then I'll start executing. So yeah, that's it.
Any thoughts, questions, comments?
Yeah. Yeah.
Okay, sorry, I just heard some. So one question I have is like, how do you because it's LLM based, right? So hallucination is like a concern. Do you have any plans on how to ground truth output and stuff like that?
I mean, hallucination usually, like, if you're hitting the context length a lot, then there are chances of hallucination. If you are staying below that context length, the chances of hallucination is slightly lower. That's my understanding of it. So which is why the agentic approach makes sense, because the agent will only plan well ahead and think in terms of smaller sub implementations of the IP. For example, how the blob gas price is implemented. So it will ask small questions, use the MCP tools to get relevant knowledge, understand it, and write a particular node, and store that node, and then move on to the other sub implementation, so that the likelihood of reaching that context length will be lower. But there are still chances it will reach the context length, and yeah, when it happens, I'll have to figure out how to. Currently, I have no idea how to make it better. Yeah.
What are the criteria if you start to compare between different clients? So how is it possible to?
Yeah. So there can be multiple ways to look at this comparison. One can be simply how the features are implemented. The other way can be that if there are any edge cases. So one client is implementing something which another client has not. So if it does a comparison, then it can say, okay, this particular client is missing this particular edge case. That can be another way of looking at it. Another thing which I haven't thought much about is learning from the previous security audit reports. So I'm assuming previously there have been a lot of security audits which captured some vulnerabilities. So if that particular knowledge base is also fed or trained, then this whole system can learn how to look for such kind of scenarios as well. So yeah, there are like 3 or 4 different ways of looking at it. So maybe for starting point, I can start with if the implementation actually matches the specs or not. Once that works fine and we have more confidence about this system working fine, then we can move on to the security aspects.
That's interesting. Thank you.
Somebody else had a question?
My question was for the PR tagging. Like you mentioned that you need labels on every PR that relates to an EIP.
Yeah, so the assumption is currently there are no labels. So
okay. So
you'll
that's like
fetch.
a different form of label.
Yeah, labeling in terms of you fetch the PRs based on let's say keyword search, for instance, using the GraphQL API, and then we store it in a vectorized form after chunking them. So it can be like we store the entire PR or even sub PRs, so that because some PRs are just way too big. I checked some of the big PRs have above 100K context length, so I can't just put that entire PR directly. We need to figure out a way to actually chunk them in a meaningful way and expose that through an MCP server. Because assuming the usual LLMs have 128K context length, so we have to work within that context length only.
And another follow-up is for an EIP number. Sometimes the EIP evolves over time, and it almost doesn't resemble its original form anymore. And I noticed with some of the LLMs that when you ask about specifics of an EIP, even if you give it like a current link to this step, it still pulls in that all the information that was long been requires.
Yeah, which is why this knowledge base concept I mentioned. So, I'm assuming this system will automatically update maybe once a week or something, update its EIP knowledge bases so that it is up to date. Yeah, but there's also an edge case, so to speak, that the LLM itself might have been trained with an older version of the EIP,
Yes.
but currently we're feeding it with a new version of that EIP, and hopefully it will take the newer ones seriously.
And also like during development, sometimes the EIP gets outdated and like the spec is in some Discord channel or some call summary. Like it's like
Or a new EIP.
like the EIP is not always the latest specification before it's on mainnet.
Okay, you mean the corresponding GitHub link does not have the latest
Like if you
specs?
open the EIP, it just has completely different.
Okay. Yeah. If it changes very quickly, then I'll figure out a better way.
That's true. Like I think one example that's kind of ongoing is Port Force. To give one that's actually salient, I haven't checked in the last couple of weeks, but I know a month or two ago that go to Port Force, it would reflect some outdated information like a year or two ago. And this is especially to continue with EIPs which have been of interest for some years. Like people know they want a history expert. That has been a goal. And it's just that the exact steps and the specificity have changed dramatically over that. But and this isn't even a case of the LLM sort of not updating its information. It's the EIP has been like the PRs go to some other EIP. I honestly don't remember the number, but apparently there's some other EIP which is not called for force, which has the current history X3. But people will still talk about for force and say they're implementing. Like I checked Nethermind released their 1.32, which is a few days ago, and which is what they say EIP 4444. They did not implement EIP 4444. They implemented a thing that is everyone colloquially talks about, but it does not correspond to the actual EIP anywhere but on. So I mean, and that's not the LLM's fault. Like that's not.
I mean, if that is not a straightforward way to actually get that knowledge, it will be very hard. Like if let's say the GitHub repo of a particular EIP, if that is actually not getting updated, and if we're expecting the knowledge base to exist in some corner of Slack or Discord, it will be very hard. So
seems like it would be useful to have like another agent that is sort of like a historian or a librarian to some of these things that could help put some context to EIPs that go through transitions like this.
Yeah.
So I just double checked this so that I'm not like so I just checked right now on EIPs, like 4.4, it is created in 2021, it is quote unquote stagnant, and it says nothing about like people might be the portal and all this various things that have come up and the exact time period and the current ways to merge and whatever. People who they won't get into details if they care. But the point is, there's all sorts of relevant, salient things, and then when people today say they're implementing EIP 4444, it bears essentially no resemblance to the thing that is called 4444.
Yeah. I think it's 7642. Like.
Is that what it is? Yeah, I think I'm told there was one, but my point is if you just kind of parse out. You see, the thing is, if we're just colloquial, if it were only that people just said it because it was a name they liked, that would be one thing. But this is why specifically mentioned in Nethermind and other, by the way, ELs, change logs. Like this is formally what they are writing, that they are implementing EIP 4444. All of the written versions of it, and when people talk about on ACD, and they all refer to this. Basically, red herring of the EIP is.
Such a system maybe could be used to index that EIP.
Yes. Yeah. There are certainly ways of remediating this for sure. But I'm just saying, this is and I don't want to hyper focus too much on this one thing. I just want to say, as a concrete example, like this phenomenon has occurred in other places as well. So.
Yeah, that's a very good point. I wasn't aware of it.
Yeah. Cool. I think we should look this one up because we're over time a bit. So thank you so much, Sato. Thank you so much for
I'm Shane. Blockchain on Telegram, Discord, this type of thing. I flew a few thousand miles over here today to talk about delayed execution, EIP 7886. A quick about me is that I've been building professionally in Web3 for the past 3 years. Before now, I was a core team member at Injective Labs, a Cosmos SDK-based L1 that was built for finance. I joined the EPF program to do more applied research that'll further the Ethereum roadmap. And this particular EIP has potential to help with the scaling of the L1 aspect, which we're all very focused on right now. There's potentially massive unlocks that it can deliver in terms of like increasing gas limits and even paving the way towards ZK EVM. So we'll take a quick look at Ethereum today and also what refactors you can make based off of this proposal. So here's a slot life cycle, 12 seconds. At the 4th second, that's when we're doing our attestation. It's the attestation deadline. You can see how most of the blocks, the time before then, is used for propagation of a block. And we keep the gas limit quite low in order to allow for only, say, 100 milliseconds worth of time for the actual execution of the transactions in the block. So let's then look at what would happen with delayed execution. With this particular implementation, we'll have a bit more time for the propagation of a block, but then we'll have multiple seconds afterwards to actually process the transactions. That's kind of the idea of delayed. And that actual extra time between T4 and T12 could also be used for ZK EVM proving as well. I understand they might need 6 seconds somewhere in the next 6 months for that. And quickly, what happens with block validation today? You can see something like the block header arrives with a state that was proposed from, say, the builder, and we'll then execute all the transactions on the execution layer to arrive at a new world state tree root hash, and we compare that to the state that we got in the header, the resulting one. If it matches, we say the block is valid. And currently then, there is a really tight coupling of consensus with execution. Basically, very crucially need execution in the validation flow. And the idea here now will be how do we decouple execution out of that? The idea is moving things around a bit. You can see for say block n+2, the header has a pre-state root field now, so it's a modified block header. And this pre-state root should actually correspond to some cache results of the world state tree from the previous block. So now, block n+2 will reference the state from after executing block n+1. And that allows us to do just a super quick header check and say a block is valid right before executing the transactions, at this point. We'll be the check will be, hey, does this pre-state root field match what we have just cached from executing the previous block? If so, say it's valid. Then we can lazily execute the transactions for the multiple seconds in the rest of the block, which is quite nice. You can see how that would allow us to have bigger blocks and lots more time for potentially MEV gains as well. So let's do a quick status of the EIP. It's currently in draft. It was created by Francesco D'Amato and Tony Wachsdotter. There is a EELS spec that's already out there for reference. And it's a potential project that could be for Ethereum. And there are also some alternative implementations that are more consensus layer focused, like EPBS. This is kind of the more execution layer focused way to get the unlocks that I've already mentioned. So we'll have a couple phases to implement this project. And the first one is mostly regarding header changes. I already mentioned that we're going to now have to update to a pre-state root, but also a few other fields from the parent block, which would be the parent transaction root, parent receives root, and a few other extra fields. So the execution payload that comes in from the engine API is going to have to hold these new fields, and then we'll have to do some header struct changes as well, like in ref, which is where I'll be implementing this project, to rip out those fields and use them as the header for validation. And also all the RLP encoding changes that come along with that. The second phase is much meatier. Ref supports a couple different validation flows. One will be like their live sync path, where you're processing new payloads coming in from the latest fork choice. And then you also have a backfill sync path, which will be for syncing nodes all the way up from Genesis, blocks all the way up from Genesis. We'll make the changes that I've kind of described, do the quick validation of those headers, and then update the execution path to run afterwards, and then do any post-transaction processing, like if the block decides to be invalid, then it becomes actually a no-op, so add that logic as well. And of course, we're going to want to do some testing and benchmarking, which I can type a little bit more in terms of the challenges. It'd be nice to do like end-to-end testing in a DevNet, but I don't think we'll have the very minor consensus layer changes we would need, which would be passing these new pre-state root fields from the beacon block body over to the execution layer, which I would need. So I would just be writing unit tests and doing the best I can with that. Other challenges are just maintaining backwards compatibility with the pre-fork validation flow, which we have today. I don't think it'll probably be a non-trivial separation. And yeah, just closing thoughts. This is just one way to rethink our current execution flow. It's a relatively lightweight change that has seemingly outsized benefits, which is one of the reasons why I like it. Thanks for listening, everyone, and open to any questions.
I have one.
Yes.
Hello, how does this intersect with shortening slot times?
My understanding is compatible. I'm not familiar enough with why, but I read a post from Tony Orstrader a couple days ago that said that it could be fine for it. Yeah.
Depends if pre-confirmation or if delayed execution or if EBS gets implemented before or after shortening.
Yeah.
But most likely it is, as you said, I was just curious how things are viewed in this context of having, 6 seconds slot.
Yeah, I mean, theoretically, if you still kept the attestation deadline at 4 seconds, and you still have the 2 seconds, which is more than 100 milliseconds that we're currently allowing for, which is kind of nice. Sure. Yeah, the more time you have, the better. So yeah, we have kind of competing views of keep this slot at 12 seconds, go down to 6. So we'll see how it goes. But I think either way, this could work. Yes.
Thank you.
Yeah, of course, man. Yes.
I guess I will say that a lot of the consensus teams probably haven't been working on this because it's just so up in the air right now.
No doubt.
It's to EPS and stuff as well.
Of course.
So if, like you said, in order for you to do some of your testing and stuff like that, you'll probably need to just tweak one of our clients to help make that work for your purposes. But I don't know if you reached out to anyone at Lighthouse yet, or perhaps, or I can help chat with you about that after.
Yeah, no, I'll be happy to get some resource from you because getting into actual DevNet for testing would be particularly cool. I mean, it sounds like pretty lightweight changes on the CL. So if I could just have a fork of the CL with my changes that I can then use with my branch, that would be great.
Exactly.
On DL, right?
Yeah. As far as I know, right now, nobody has really been putting too much time into it just because of the uncertainty right now. But I guess if you do it, great.
Yeah, no, for
You'll
sure.
be helping out with the client teams. Yeah.
No doubt. Thanks.
Yeah.
Cool. Yes.
Yes. So I'm a bit confused how this actually works. So is the trick that because you change the header to also reference the previous state, is that the main trick that allows you to extend the execution time?
That's exactly the main trick. Because instead of having to wait for all your transactions to process before you can say payload is valid before that 4-second attestation deadline, you now are just checking against a cache of the previous block's results with the header, and just boom, quick. then you can just like spend the rest of the slot actually executing this block's transactions.
But is that cache, is that based locally, or is that like you actually reference like already developed basically?
You would have to like cache the like root state of the previous block, and also like fork states as well too, because you're always going to be having like some potential reorg or choice update. So you're going to have like a hash map in the end of like block hash to these execution outputs, the pre-state root, transaction, like parent transaction root, this type of thing, just in case you have to switch. And you know, some complexity with if like you have a node restart, you might want to have like a replay of a block at that point to grab the execution outputs that you're missing.
Right. It's also the execution requests, like because when you make a deposit or a withdrawal from different chain, it emits like a log via a smart contract interaction, and that one goes into the request route, so that one is also delayed. It's like the entire execution that gets delayed, not just the state route update.
Right.
The state route update is not that big of a deal. It's like we want to gain more time to actually execute transactions. So yeah.
Yeah. Anything else? Okay, thank you, Shane.
Awesome.
Yeah.
Cool. Go ahead. Hi, I'm Lee, and I'm working on the PRDS optimization proposed by Grundy, and my mentor is Solis. And let's do a quick poll. How many of you know like DS, PLDS, or data availability sampling? Raise your hand. Okay, cool. Most of them you know. Yeah, let's go. So let's say we already have PRDS here, and also like Grundy, they get like a library called Rust KZG, and it's also a good library. And we want to see like if we can make the DS use this Rust KZG library even faster. Like we can save a lot of time with like MSM and NTT operations. Let's see how much. And so the quick recap of what is data availability sampling. And data availability sampling, the idea is like it's very simple. We want to decouple the data from the for node to some specific like storage network. So which means like a light node and for node don't need to store all of them. Because a lot of data actually knows that useful after a certain period of time, like raw data. But the tricky thing is like you want to make sure that all the data are available. That's very important for the not only for verification but also for like reconstruction. Let's take an example. If the like a roll up just crashed and some money already deposited locked in the roll up, how can we like reconstruct the whole state? The idea is like the L1 for node or validator, they can take the data from the DS node and then help the L2 to reconstruct the whole state. So which means even the even if the whole L2 crashed, let's say the whole team like just run away, but L1 can still guarantee like all the state is safe and all the money can be retrieved. So that's why it's much better than a lot of other solutions, and it's quite succinct and beautiful. Now we are using the KZG commitment. The KZG commitment is actually amazing for this part, because for DS we actually have quite a lot crypto requirements. Like say, we can now simply, actually we can use a Merkle tree as a commitment scheme, but which will involve a lot of more queries and much more complex, like you need to check if the code is consistent. Not only the position binding, soundings, all this stuff. You also need to check if the code binding is there. And but for KZG, if we assume like AGM model is safe, then KZG is safe. And for KZG, it naturally actually can fulfill all these requirements. So if you don't know a lot about crypto things, you just don't think about it. KZG is already good enough for this situation. It's safe until so far. And so if we want to use a KZG, I mean, it's already a lot of libraries, like they already support
KDG. But we also have something called C KDG. And Rust KDG want to do something is like they replace C KDG with Rust, all the Rust interface, and will give like APIs like C KDG, can use backend like Arcworks and like these curves to construct the KDG proof, and more efficiently and also Rust native. Let's say KDG has something like some major time consumption operations like multi-scale operations, NTT, and setup. Setup is quite big, but I mean it's roughly okay actually. The setup is not the things that we are going to deal with here. And also the batch verification is quite nice, but to generate the batch proof is actually quite like time consuming also. And now Rust KDG already support multi-backend architectures like BRST and Arcworks and also others. And BRST already and Arcworks already support parallel and GPU. So we can see some performance initial benchmarks from Rust KDG. If you cannot see the details of the figure, I can, it's too small. I can briefly explain that. Basically, you can see if we use like GPU, the performance get huge improved, and it's also very natural, right? Because for the whole like KDG generation, I don't see any parts we cannot parallel, right? NTT is a tricky part, but we also have some way to make NTT faster with like GPU and all these accelerators. But the thing could be more interesting because for compare with native like KDG, for pure DS or DS, we need actually, it would be better to use like a batch verification, right? And if we can do like batch more efficiently, that's gonna be interesting. And also like they have different backends. So for different backends, they will, for different operations like MSM, NTT, and all the commitment verification, they actually have different performance. That's actually natural, but also very interesting, because for different tasks, they may actually use different backends. They will, the performance will maybe huge different. But for Rust KDG, we all have the same API, right? Which means you can simply swap from, like, change from this backend to the other one. So what we can do is like we can have a backend selection. That's actually kind of like a low-hanging fruit, because if we have already for PRDS, all these like tasks are quite clear, right? It's not like so many complex tasks. It's quite actually simple tasks. So if we know like which operations can be done with this backend, then can just use it. Right? And another one is if we can do more parallelisms for DS specific things, and also like GPU is good, and if we can do more, and also memory layout. So we can have like another layer, but maybe not really layer, but we have like optimizations for like Rust KDG to support more complex like DS operations. And yeah, this is already a thing I mentioned before, and so the plan is like to first understand, because I think I know the KDG, how KDG works, but for Rust and also the DS work. But for Rust KDG, I'm also new to that, so I'm actually still learning that. And then the phase 2 gonna be like we developed like a backend selection mechanism, and also like say parallelization and GPU optimization. But I highly doubt if the GPU optimization could be fully done. We can try some, but if we can finish all of them, that's gonna be amazing. Yeah, because actually once we need to use GPU for acceleration, there are usually a lot of annoying things. So now the current landscape is here. We can also skip this part. And yeah, for us, like the most important thing is like we need still keep the Rust KDG, and we need to ensure that all the operations is stable, and also we can starting to maybe not be done by the this project, but we can start thinking about like not only the proof is a bottleneck, but also the network. There is a quite new paper recently released by Benedict and other people. Yeah, they are talking about the bottleneck of the DHT for the KG selection. That's kind of actually quite interesting bottleneck, because considering we need to use for the safety, we need to like have a lot of like DA nodes, like storage nodes. But how to select which one to build a connection to query and to reconstruct? That's actually quite interesting, and usually the network delay is more than the proof, right? The proof we can use a lot of hard acceleration tools to make it faster, but for the network we cannot do much actually usually. So not only the proof need to be fast, also but need to be succinct, which means bandwidth also need to be considered. That's why batch could be interesting, right? And yeah. That's basically my plan. And for the learning phase about Rust KZG, I'm actually preparing something like Rust KZG book now. I can show you the first chapter. It's written in Chinese. Yes, because usually we're starting from English, right? And then we have like a lot of nice guys to translate to Chinese. I say, okay, I'm a Chinese native speaker. Let's start with Chinese and then translate to the English. Yeah. And so this chapter mainly talk about. I mean, you don't understand Chinese, but I mean, maybe some of them you know, but but you understand the code, right? Yeah, right? So this chapter introduces some like basic idea for electric curve and how to use Rust KZG and all this Rust-based curve like native backend to generate, let's say, to do the scalar operation, to pointer operation, and scalar multiplication. And so you can use this notebook and examples to step by step to learn how to use not Rust KZG, but also like Rust backend, all this curve stuff. So yeah, I think that should be good. I mean, at least it's good for me to learn the stuff, right? And I think that also should be helpful for many other people, because both like elliptic curve and Rust, the learning curve, we all know it's kind of steep. So it's not that easy. And when you put two things together and without like a clear material, people just feel scary and never gonna use it. So I found this one step-by-step thing gonna make people, especially developers, feel like life a little bit easier. Yeah. So yeah, that's all. Questions and remarks. Thanks.
Yeah, I have a question. Please. In this last notebook, what did you implement, like point addition, multiplication by scalar?
Yeah.
What else, like, did you also implement pairings?
It's not at here until so far, because the verification of the multiplication is kind yeah, here. Yeah. Because they already have a like you can say this one. And we also discussed like we have like 3 groups or maybe sometimes 2 groups like G1, G2, and GT. And why this pairing works from here, like pairing verification example here. But we will not go very details to see why the pairing here works. We only show, okay, if you use this API, and ideally the pairing will work. So for developers, you don't really need to dig into the rabbit hole of the detailed crypto stuff, right? And yeah, we just know, okay, we have this tool, and this is how it intuitionally and how it works in practical. And if you want to learn more about, like other people, if we want to learn more about crypto stuff, we already have a lot of nice courses like Banai's course, and yeah. Any other questions?
I wanted to ask, what are you using for GPU acceleration? Is it CUDA or?
It's not done by me actually. It's the benchmark now. It's like for GPU, it's done by Rust Cage already. The brand new. I think they use like both Teslas and NVIDIA's. They check both of them. Yeah, and both of them looks pretty fun. I mean, it's like especially for DS part. Let's think about it. All the things can be parallel, right? I didn't see any parts that cannot. But the reconstruction part is kind of interesting, but we don't really do reconstruction a lot. Ideally, we shouldn't do reconstruction anytime if the chain is still survived. So, but the reconstruction itself, it cannot be easily accelerated with GPU. But the verification, batching, all these parts should be able to be done.
So, thank you.
Yeah, that's all.
What is puzzle? Yeah, this is the diagram for the puzzle progress. Yeah, so in each slot, a set of validators is selected as inclusion list committee members. Each member build and gossip one inclusion list according to the view of their member pool. Yeah. The proposer and the attester of the next slot. Yeah. Monitor and validate and store and forward the valid inclusion list. Yeah. The proposer or the builder will include transactions from all collected inclusion list to its blocks. Yeah, and propose it. Yeah. The attesters only vote the proposer's block if the block include all the transactions in their stored inclusion list. Okay. How to implement it in Granda? Yeah. So I plan to split it into 3 parts. Yeah. The first, we can define types and handle the external interactions. Second, we can focus on the duties of various roles. Last, we can implement various tests. For the types and the external interactions, it consists of 2 parts. One is SSD types and P2P gossip. Yeah. The other is execution engine API invocation. For the part 1, the focus is implement the inclusion list and the signed inclusion list SSD codec, and followed by implement the handler for gossip publishing and receiving. Yeah. Regarding part 2, the tasks include get inclusion list and update block with inclusion list and point invocation for the use as a validator, and modify the new payload request with the argument inclusion list transactions. Okay. According to the spec, I've thought out the six duties of the following 4 roles. Let's take a look at one by one. Yeah. So the first duty for the validator, it need look ahead the inclusion list commit assignment. Yeah. Also sorry, the diagram is not not true. Yeah. So after diving into the code, grounding code, I think we can add a structure similar to the own beacon community members to maintain the inclusion list community members. Yeah. And we can implement a function similar to update beacon community subscription to update the assignment at the start of each epoch. Yeah. But we don't need update the sublight subscription because the signing inclusion list is a global topic. It's not in any sublight. Okay. Validator also need valid store and forward the side inclusion list. Yeah. So follow the branding's design. Yeah, we can register a callback function like onBlock to invoke the fork choice module for validate the signed inclusion list, and we should add a catch. Yeah, catch it if it's valid, and return the acceptance. Yeah. If we return the accept, the P2P layer will automatically forward this signed inclusion list. Yes. Okay. The last duty for the validator, it need valid the block with the inclusion list transactions. Yeah. So we need change the process block function. Yeah. So also follow the branding's design, we can add a new branch. Yeah. And call the modified new payload endpoint in the engine API. Yeah, with the argument inclusion list transactions. Okay. So as inclusion list community, it need build and gossip the inclusion list. Yeah, how can we do that? So there is a main loop for the ticker. Yeah, so I think we can add a new ticker handler to call the new get inclusion list endpoint in the engine API that at the specific time. So branding divide the each tick kite is 1 second for the 12 seconds the slow time. Yeah, so you can add a new tick kite here. Yeah. After get the inclusion list, the validator can use it to build a signed inclusion list. Okay, similar for the similarly for the proposer, yeah, we also need to add a new ticker handler to call the new update block with inclusion list endpoint in the engine API to force include the transactions collected from the order inclusion list. Okay, the last duty is for the attester, also the sync community. Yeah, it need a vote block which include all the transactions, all the inclusion transaction list. So how to do this? Yeah, we can utilize struct chainlink. It holds the block information and with some metadata. Yeah, so we can add a new metadata here. So it can store whether the block contained all the inclusion list transactions, which can be used by the header block group function to return the correct handle when a tester to vote. Okay, so for testing, I think regarding the regular unit tests or the bench test, if needed, we need also add the new spike tests for the fossil, and because there are some local DevNet, so we also need to add local DevNet interop tests for the fossil. The roadmap is divided into 5 stages, aligned with the 3 implementation parts. Yeah, the stage 1 and 2 cover the first part. Yeah, I think it need 1 or 1.5 months. For the stage 3 and stage 4, address the second part, maybe need 2 or 2 months. The last stage is focus on the testing and the optional P2P RPC endpoint. Okay. Any questions?
Any thoughts, questions, comments? Okay. Yeah, we're a bit late, so let's move along. I guess. Thank you so much, Peppa. Yeah, awesome. It was very well, very detailed. Yeah.
And so my name is Fahil, and the project that I've chosen is implementing 7805 for Aragon, which is the fossil implementation for the Aragon client. And yeah, Aragon client is mainly like mostly used as a full archive node at the EL level, but they also have like a consensus layer built inside of it. So yeah, this EIP basically is meant to be built for both the EL parts and also the CL part for Aragon. And yeah, what's the main idea behind Fossil and why it was introduced was to tackle these issues. And currently, like how block building is being done is like we know that it's most of like the few people who are currently building blocks, and most of the block building is being carried out by strong like very strong centralized entities. So that's like centralization aspect of the block building, which isn't great. And also the censorship resistance, which is also like people or the block builders can like have the power to censor the transactions or of people, and they have the power to control what gets in, since these two things are tied to each other. And yeah, this is the high level overview which Greg also discussed. And sort of at each slot we have like 16 members who get selected as committee members, and they basically search for the transactions, and these searching can be done by any sort of any sort of transaction selection process can be done here, either based on priority fee or either like random, or yeah, it can also be based on how long a transaction has been pending for in the mempool. So yeah, once each member have an IL view, they basically post it on via gossip sub to the P2P network. And yeah, the global topic, each member sends it, and the currently in the spec we allow each member to at least send the IELTS twice, which I'll discuss why it's twice and not more than two, or why not less than one, or why not less than two. And yeah, basically builders, since it's on the global topic, builders can basically listen for that topic, get the IELTS, and if let's say if like some builder have missed the inclusion list, they can also they have also like an HTTP endpoint built inside, so they can query yeah, and get the inclusion list from there as well. And yeah, then once we have like all the inclusion lists at that time slot, we basically, the proposer builds the block, and then the attesters then verify if the block has been built, and also checks the IO constraints on the block, that if all the IO constraints are also being applied. Yeah, so these are basically like a very high level overview of the changes which will be done on each layer. And for execution layer, it's basically yeah, before like the transaction execution, when the transactions are being executed, it will check if the IOs, if more IO transactions can be added, if there was like a transaction gas, which is like if the transaction gas was less than like the current block can support more transactions, it will then send an invalid response to our consensus layer basically. And yeah, for the engine API changes, we have introduced two new methods. So we have like get inclusion list v1 and then update payload. And with get inclusion list, we can basically communicate the inclusion list from EL to the CL. And with update payload, what it allows you to do, since the payload ID has already been generated, what it will do is that on that same payload ID, it will take like the inclusion list parameter as well as an argument, and then for the same payload ID, it will then add like the transactions for the previous, for the same block, it will then add all the inclusion list transactions for that payload. And on the consensus layer, we have like fork choice changes in the P2P topics which are also added. So for the fork choice changes, like we have to also check for the IOs which arrive, we store them or cache them, and then basically why we need to do so is we need to check if like another the same member has sent like two IOs, and we need to make sure that they are same and not different. So if they are different, we then lower the score of that member. So yeah, and we don't include or forward IOs from that specific member. And for the P2P topics, as like I mentioned in this diagram, we basically the topic will be there, so like each member can communicate or forward their IOs. And yeah, this is like how IOs are built. Basically, it can be, it depends on the client implementers how they choose, but yeah, these or more can be added, like how you sort of build your inclusion list. It can be based on the priority fee, it can be like how long the transaction has been pending, or some custom logic, how yeah, how the implementers select. And yeah, for security, we have like one of the sort of one main security consideration, which is that what if let's say single member sends two IOs or more IOs. Now in that case, like when they send more IOs, we potentially have to make sure that those IOs are not forwarded anytime soon or next from those members, since their peer score will be dropped. And yeah, the reason is because they can easily confuse the other people, and how they can confuse is that, let's say Alice send like TX1, TX2, TX3, and then she sends three different transactions in the same IO. Now the attester will be confused against what they should check the block to verify, to basically verify if the block is valid according to the IO. Yeah, according to the IO So yeah, and the reason they have decided for 2 is because there can be a sort of scenario where they accidentally sent the same IELTS and they don't want to sort of discourage or not discourage, like they don't want to say that this member is bad because it was an honest mistake. But let's say if they sent 2 IELTS but all of them were different, then we need to discourage this behavior. So yeah, also like 2 and the number of IELTS are restricted because we need to preserve the bandwidth, and also yeah, we basically don't want to flood the network with a lot of inclusion lists, and yeah, that's basically like it helps excavate attacks, excavation attacks, and yeah, that's pretty much it.
Hi everybody, my name is Vlad, and I'm here to talk a bit about my plan during this EPF session. Also, I'm gonna tell you about where I come from and what I want to do here and what I want to do after, because I've kind of like a multi-stage thing. So I'm gonna start with me. I think I'm a developer for 20 plus years. I started in the gaming industry. I jumped in the Web 2 stuff, and yeah, I went from leading teams to building my own projects to consulting for people. So I kind of done a lot of stuff in that area. And I was on a right track to have a proper career and do what was expected of me. And then I just said, I don't want to do it anymore, right? I just stopped, right? So my shrink called it real-life crisis. I see it as an opportunity to do something else, something that would give me, something that would fulfill me, right? So then I met Dan, who's right there, really smart guy. He was already working on EODS, which is a way of having delegations in protocol. We talked a lot about public goods and just trying to, use our skills and use the infrastructure and the community in ETH to do more, right? Yeah, then I decided to work with Dan on EODS. There was quite a lot of work there. And I had to go through, the normal hurdles. Look at the specs, learn how to read them, compile them, look at the tests. So the learning curve was quite something. But yeah, I made it. What I want to say is that during that time I found quite a lot of places where I think we can improve ETH as a whole. I'm really keen on pushing UX stuff more. Basically, I want to increase the adoption for developers, for people, for anybody that wants to use this. It should be, I think, way easier to jump in than it is now. At least that was my experience, right? Yeah, so I decided to just go for it and see where that takes me. A bit about EODS, and I think we'll be releasing more info this week and the weeks that follow. Me and Dan just had some initial discussions, then we built a small prototype just to kind of validate our ideas on how things could work, just a super small Python project. And then we started working on the specs themselves. We are nearing the point where we want to kind of make things public and involve the community and you and everybody who's interested, mainly to get some feedback, right? Because we've been working, together, limited help, limited feedback from outside, and we do want to involve the community. So my idea for this EPF initially was to write the tests for EODS and also have a proof of concept implementation in a client, just to kind of understand what it would take to implement it, to size it, try to weed out things we forgot, and yeah, have something we can benchmark and play with in a testnet somewhere. So yeah, that was what I was supposed to do, and I'm still gonna do it, but I'm gonna do it a bit different. So I was looking at clients and I found Lodestar, which is a consensus client, and that's easy to find out because it's written on their GitHub page. I also saw they could use some help and nobody was really jumping in. My last couple of projects were TypeScript, so I still have some muscle memory. So I said, okay, I'm gonna definitely want to help the guys. Yeah, so this is my plan. I'm gonna wait for feedback from community, EODS wise, and keep polishing the specs and so on. But mainly I want to start helping the Lodestar guys. So they have a couple of tasks they posted, some Mirafile support and backfill. I cannot tell you a lot about that because I couldn't jump in and dig too much. But they sound like something interesting I can work on. I'm also not sure I can fit both of them in the EPF a lot of time because it's like we have 4 months left. So I'm gonna try my best. And then once I'm done with that, I'm gonna start doing the tests and the proof of concept for EODS. By then I will be quite familiar with the architecture of Lodestar. I'll get to meet the team, so yeah, I guess that would be interesting. So I'm definitely gonna do the tests and the proof of concept. I just cannot commit to fitting them in these 4 months, right? Because the proof of concept itself, the implementation in a client is quite a big task for one guy. So yeah, that's gonna be my future moving forward. Yeah, and that's it for me. Short and sweet.
Thank you. Awesome.
Lodestar recently announced that they are migrating to SIG some of their more performance critical components.
Okay.
So it's not a pure TypeScript.
It doesn't have to be, right? I still have not gotten in touch with anybody from their side. So there's a lot of stuff I don't know. But yeah, we're definitely gonna connect and find something to do. I still want to do Lodestar though.
Yeah,
okay.
We'll talk.
Yeah.
Yeah.
Yeah. Cool.
Nice. Awesome.
Yeah.
Awesome. Thank you a lot.
Yeah, thank you guys.
Yeah.
Keep doing it.
This is so great.
Amazing, perfect. So, hi guys. This is my project. My name is Irene. So, just a bit of context why Ethereum, because basically I'm super interested in like the ethos of decentralization. So, one of my passions has always been like knowledge graph and infinite sum game theory. So this comes together for me with Ethereum, the community, the principles, the values. And yes, my project will probably also gonna be on Lodestar. Basically, I was checking through the proposals and I found that like Prism was migrating also from Kurtosis, from the test framework to Kurtosis. Then 1 week ago I met a guy which is also a core developer in Berlin, and he told me that also Lodestar was migrating, and since I'm more familiar with TypeScript than Go, probably I'm gonna pick the Lodestar way. So motivation, what? So client, Lodestar, what the testing environment, and the scope basically is to help the team. So I'm gonna probably focus my EPF journey helping the team switching from Lodestar proprietary sim test framework to Kurtosis. What is Kurtosis? Basically, it's a testing framework widely used in our ecosystem, and basically it's a standalone development and testing platform for launching environments of container services. In our case, so in the Ethereum ecosystem, on the top it's built the Panda Ops team built this so-called Ethereum package, which is basically able to spin up a private Ethereum testnet or DevNet with a multi-client support. So whatever you want to build, this together with Ethereum packages is going to be able to create it. And here I added like a bit of code snippet on how you can do that. It's pretty straightforward. You can, from the CLI, you just run Kurtosis, run, etc., etc. Here we have two types of examples. So on the left side, this is how it looks like having a network with three nodes. Here the pairing is like get together with Lighthouse and the one node with Nethermind and Teco. On the right side here is what I was trying during the week 2 of the EPF and started to simulate this network with one node Bezu together with Lodestar. This is the output of kurtosis. It's small. Lodestar current testing status. So why migrating? So basically, I was chatting with the team and they explained me that like now the architecture so far is like these 2 layers. Layer 1 is a network bootstrap layer that probably is gonna be the one that will be migrated at the end of the migration journey, and the second one is the assertion framework, which is still gonna be unaffected. So. What are these assertions? Basically, they simulate this type of default testnet, and then they do these regular checks along the way during this simulation process, and they assess how the testnet works are working. And yes, so basically they check for specific condition and performances. Everything is made through API. HTTP request, so everything's kind of still already, you don't access the code. Here I also put an image of the current simulation report. This is how the current testing environment looks like. This is the assertion that they are using. This is a screenshot from their code base, and yes. Go. So the point is, my project is gonna like be an exploratory phase together with investigation phase. So it's not like strictly defined so far how the migration is gonna work. We are gonna be researching, testing out stuff, so breaking and building again. And yeah, so migration feasibility, go no go decision points. So this way or the other way. Compared to Prism, that where they are gonna like switch entirely their current testing framework, probably lots are gonna have this so-called hybrid approach, so not migrating the whole code, but I'm gonna discuss with Phil again later. And yeah, so my scope is basically support the Lobster team and run the sim test and testing out the migration. The main question here is like, can the current assertion framework be maintained while using kurtosis for orchestration? So basically, do you remember so this type of text code is going to be maintained or also transition into kurtosis? This is what I'm going to be testing. And yes, Ango is always like the ecosystem tuning standardization. Basically, kurtosis is not just used from Lodestar is not the one trying to use kurtosis that everyone is kind of uses. So that's my goal. And that's it. Feedback and questions.
I think you can check out the author tour, which is
exactly.
For the assertion.
Exactly, that's the point. We don't know yet whether to transition everything to a server or keep them separate. Yeah, that's the point. Next question?
Exactly the same.
Exactly. Yes. Perfect.
Awesome. Any more feedback or questions? Okay, thank you, Ari.
I am Chet, and this is something that I just thought around since yesterday after the Beam Day, and this is more so of a feedback and discussion sort of thing going forward. And if the slides look bad or rough around the edges or even sharp at center, I'm sorry, just be careful. And the slides are just made in a hurry to look smart within a bunch of smart people, so I can fit in. Alright, so yesterday we had the Beam Day, a lot of folks, a lot of familiar faces from yesterday, and one thing especially coming from a DevOps background that struck me was that observability has always been treated as like an afterthought, a second class citizen by us code developers. So I'd just like to briefly touch over why observability should never be an afterthought, especially given that the current scenario and going that we have a beam chain that development is going on, and how we can standardize a lot of things. So, yeah, early integration, blah blah blah, whatever. Let's skip it. So, technical depth. The beacon chain that is live right now, the specs were finalized. It has been, I believe, more than around some, like a lot of years essentially. So, yet there is no to minimal standardization for observability across the clients on the CL, and each client, of course, they're free to do their own approach to monitoring. And but this what's the result of is that multi-client observability today is very hard. There are tools, especially big thanks to PandaOps, there are some tools that do give us a workaround, but on a client level, detailed metrics or other observability pillars are still not present. So the opportunity with that's supposed to be beam chain, I'm sorry. So beam chain is that since it is something new that we are starting from ground up, there are not a lot of teams, not a lot of concrete development, even especially given the specs not being out yet. We can have a standard for metrics across the clients. We have a better understanding of a lot of things. So we can just, observability is not just your metrics, it's not just your logs. I will have a crash course right after this, but now we have a lot of better understanding of MEV. We are trying to prevent MEV and trying to, a lot of folks are trying to maximize it. We as code developers are trying to minimize it. So we have a lot of things that we can get out of just from observability that we do not have today, and how we do it, we'll touch on that later on. So this is our chance to standardize observability today before teams diverge. Zeem does something, Ream does something else, C folks do something else. We can have a standard set today. And the first testnet, there is still time, but we know things will break. Performance will be unpredictable. We will not know, we will not even have a benchmark because it's the first time we're running that change. So it will all be very helpful. So this is all that we will try to achieve if we have something like this. From the get-go, we have the first testnet for beam chain. So real-time consensus. These are just very basic things. We will go in depth. Alright, this is what I studied in my bachelor's for past 3 years or so, just consolidated, watered down. So metrics is just one part of observability. We have logs, which we all use to debug somehow, and we have traces. How we can use those today is just like a log. We can have a human readable form where data X makes Y due to Z reason, let's say network availability. Metrics are mostly numerical, but could be our strings or any other data essentially. But metrics also has various types, so we also need to make sure from the get-go if we want our metrics to be counters, if you want them to be summaries or whatnot. So, and then traces, your trace flows, all of that, and we can even have it in much better form. But what I want us to focus on going forward with Zeem is profiling, which is a new paradigm in observability, but it correlates your other type of observability parameters with other things, mostly time. So how much time, since we have had a huge discussion about signatures, their aggregation, the size, so how much time is my signature aggregation taking? Your metrics will just tell time for, let's say, the call. But between calls, between clients, you cannot tell anything. That is where profiling comes in. So this is the custom profiling section is what are some examples that we can have going forward with the development. So how much time is my aggregation taking? It's like your trace is given an additional information data point, mostly time. So there are some existing tools. What's the difference and why do we need this is we have, thanks to PanOps, so Ethereum metrics exporter. It is again for metrics A. It works great across clients very well. But the shortcoming is it uses the standard APIs that we expose. So I can track how much is the JSON RPC response time, but I will never know how much CPU did the client use. I will never know what was the flow of the request. Where did the bottleneck come from? That is again the limitation of the architecture that we're using, and again, because it had to be standardized across clients, it made sense. But right now, given that we are in very early stage of development for Beam chain clients, we could have these things from the get-go, so we get a much better understanding, and down the line we have a much better playground of data that we can use to optimize things. You know, we create new EIPs and we can create new optimizations as code developers based on this actual data. And there is Tracer and a lot of other tools. So this code, just ignore it. It's just very bad examples of things that we can do, but these are practical recommendations on how and what approach we could take with observability when we are going forward. A lot of Ream folks are over here. Grape from Zeem, we have talked, so we might not know each other with face. So Zeem folks are here as well. But so and Mario just told me that there are clients like Geth which allow for hybrid models for data saving for metrics, but also your data saving for logs, which is and your traces and all that. We should ideally aim for a plug and play so that we do not get like logged into a ecosystem or a standard essentially. That is A. And second thing would be I've seen it myself. A lot of organizations, a lot of folks using these just because we have observability as an afterthought get logged into something like, say, like Datadog, like New Relic, because they do not think of it from the get-go. And now we talk about decentralization. Of course, we can talk about it a lot in terms of the infrastructure we are using and whatnot, but we get logged in by some observability vendor which has full control over what we see, and if they want to turn off their cute little buttons for metrics, they can go right now. So the idea is, again, this is something that I would like some feedback on as well, to have pluggable structure, not just for databases, of the metrics that we're going to use and the standards for it, and other tools as well. So avoid vendor lock-in, built-in client instrumentation, since that we have example of the PandaOps tools which works across the client but are not as detailed because of the limitations, and then standardized metrics. Of course, your implementation will have different, let's say, labels for your metrics, but it's always good to have, because a few things are always going to be standard, right? We can have those standards at least. And real-time profiling, and this was it. So what is this? How many balance standards? Okay, yeah, this is the question for you. So if there is any feedback, I'd love to get that. It's very impromptu presentation, and thank you for your time.
Anyone? Questions, thoughts, answers?
Yeah.
Yeah, it seems like there's different categories, and obviously you presented them as sort of different approaches. You said logs, metrics, and of course they're different things.
Mm-hmm.
Some of them seem, logs and metrics are quite conventional, as you say, like they're not particularly standardized now, but in every client and the Beacon and CLE world has some selection of them. And obviously, you say PandaOps.
Yes, yes.
Others are, as you noted, less conventional, but I'm kind of curious in terms of your vision for things that. So there's some that are sort of, let's call them policy-ish. There's a standardization of metrics, things of this sort, and we have at least one person here who I know is pursuing these things. But at least in terms of a technical measure, those are. We know how to do that. We know how those work. for the debugability and profiling, I'm a little curious because this is a couple of points. Traditionally, quite language dependent. Also,
Definitely.
there's also and even in terms of its feasibility, in terms of like dependence and optimization level, in terms of debugability, traditional debuggers stop the program. I mean,
could you come again with that?
They
please?
stop the program.
What exactly? Sorry, could you repeat? What exactly stops?
Traditional debuggers. And here I include things like RR, so I'm not just in the sense of, well, they step forward like GDB or something, but even the ones we can time travel and all of that, they stop the program.
Right.
Like, I don't know, that's kind of a showstopper for me in terms of like using them in a live, real-time way. I'm not quite sure, I'm curious, so one question is, how practically do you envision that happening? And also in terms of profiling, there's a similar thing where, of course, people can have built probes, like you look at Linux and some of the EPF stuff, I believe that it is, and so there are certainly ways of building profiling-ish things.
Yes.
Again, that's always, in that Linux context, for example, they have to be very careful about the performance overhead. And if you look at some of the demessage like kernel logs, sometimes it will just say, hey, look, it's decreasing the frequency, the sampling frequency, because the sampling overhead is too high. And so I just wanted, I guess those would be my questions.
Yes, sure. So let's. I believe that's a bunch of questions. Let's have them.
A bunch of things.
No worries. So this is one of the ideas submitted to PanOps by for the EPF, and it's just metrics. Let's just start about the standardization thing, right? So the point of standardization is not to force teams to use one specific way of how they approach their, the core logic that is going to be part of the client, but to ensure that the visibility of the core logic is standard across the clients. So if I go to, let's say, Zeem, if I go to Ream, if I go to any other client, the core things, let's say, how much time is it taking to aggregate the signatures, how many signers are there, and anything basically, right? So at least that, and if you want to do it in some weird way or some very smart way, that is up to the team, but at least as an observer, I should know, right? So let's say you run up a node, right? You want to be able to see what you are, like what exactly is your client doing, right? But let's say you find something that, this client is not working for me, I want to switch. Now you switch to the other client and the other client does not even show what made you switch. So let's say it was the time taken to do something, some action X, and now you go to client Y and you do not even have that metric, right? So there is you cannot even compare. So that is the kind of standardization, not in terms of the core logic. The second major thing was the overhead, right? So again, it's always trade-offs for us. So you want to have also with metrics, especially if we talk about metrics. So we have all these labels, but the thing about metrics, especially in Prometheus, is that every label that you add, each entry, each unique entry will have a separate time series database. So let's say I have just 2 labels, but each of the 2 labels has like 50 possible options. So it will be 50 into 50 number of time series database that the Prometheus will make. So we want to limit those things. So again, that is where we do performance optimization for observability. So again, it's at the end of the day, yes, it is a trade-off. Boring answer, I'm sorry, but it is how we deal with things everywhere. So we'll have to make sure we have enough data to allow decision making and improvements, but also not too much data that our clients have issues in performance and we fall back on the actual use case. Boring answer, I'm sorry.
So I mean, and to follow up a little, I mean, even actually what you put up there, like, so I would say some of those there's a distinction between some of those are accessible at the application layer of the CL, and others are not, because some of those are gossip not actually all of the things labeled as gossips and metrics are inaccessible, but some of them kind of are. So in particular, including duplicates is not actually accessible, generally speaking. I can't speak for all libp2p libraries, but like the function of the libp2p library is partly to do this abstraction.
Yes.
And to do this duplicate detection. And one of the many things it's doing. And
Under the
usually it is not supposed to deliver the same message over and over and over again to the client, which means that the application level layer of the client is not going to be able to even ever see what the duplicates are, which means that we are looking, those are a kind of random mix that are sort of unlabeled which is which. Some of those have to live in the libp2p layer, and some of those can live in the application layer. libp2p is not just like some Ethereum library. libp2p has other use cases. And so it's worth being a little careful there is how, like in terms of the standardization process, like how this is not simply asserted by Ethereum on behalf of all libp2p.
Right, we're not standardizing what libp2p does.
But you are. That is.
This is the metrics that our client would expose. So, see, let me give an example. So this is my function, right? That is libp2p something doing over here, right? Now, could I not profile this function? Could I not just call metrics from here to this point, which was the libp2p call? I'm not doing any changes to libp2p. I could easily do that. And that is like near to zero just for one thing, performance overhead. And you are not changing, you are not forcing libp2p folks to align to Ethereum. That's the very basic example. But I hope that clears it up. And also this is basically labels on the client level. So this is what PandaOps wishes to standardize. So this is what Nimbus is doing.
You want to update a table and open a PR because it's like a year old.
Yeah, it is very old, and I believe some of it has been worked on already as well. I'll have a look at it. So when we're not enforcing anything on libp2p or any other library, which should never be the goal as well, right? So we are working on Ethereum, and it should be aligned with our standardization, not forcing anybody to enforce our standards. That was the point of the presentation. I'm sorry if I couldn't convey it in a way, but that is what I meant from the get-go. Any other questions?
I think we need to cut it for time.
More of a Q&A, I guess, than a discussion, because I wanted to have like hour to 90 minutes, and we have like 30 minutes to do it. I'm good, thank you. So let's just get going. Thank you so much for being here. We got Phil from Lone Star, Manu from Prism, and Dan from the EPF 5 working on EODS independently. All kinds of different people here from different backgrounds, and I would like you to share kind of your journey, what brought you to the core development, and how was it for you to get started. If you can just tell us what was the journey for you, what brought you to Ethereum, what was the first contributions you made, and how was the journey for you? And let's start with Phil, because these guys are from EPF. They will have a similar story a bit, but Phil, and I think you have some military background or so. I'm curious about your journey. So
my journey. So I'm not really I didn't study computer science and study computer engineering, none of that stuff. I came from a IT background. I used to work in the Canadian military. And through there, I learned a lot about cryptography and stuff that would make it easier for me to understand this stuff. So everything kind of aligned. I got into blockchain in general in 2013 when someone sent me some Bitcoin as an example in 2013. From that point on, I was lucky to have grown up in Toronto, and there was a big Bitcoin and Ethereum scene there in the early days. So started learning a bit about Ethereum at that time in 2015 through the Homestead fork when Ethereum officially got out of its testnets. Been following that throughout my time, and then only went full time into Ethereum in 2021 when I joined ChainSafe. So from that point on, I had been contributing to Web3.js and to Lodestar. We proposed our first block on mainnet in 2021, November. From that point, basically stayed with the team. I loved the work that we were doing, and pretty much kept going with it from that point on.
Awesome. Yeah, thank you so much. So it's been many years since you started looking into crypto to actually start working there. Like, what were you learning, or what brought you to Chainsafe? Like, kind of skipped the part. Like, how did you even adapt?
Yeah, so I was kind of just like following the development. I was a tinkerer, so I used to. One of the first coins I mined was Dogecoin.
Nice.
You know, with my with my home PC gaming computer that I wasn't using, it was like an old Radeon, like 4000, something like that. And then through that, just started learning, doing a bit more things, and slowly gaining the knowledge that I needed to eventually feel comfortable to even contributing. So my journey was a little bit longer and a little bit slower because I was working full-time military and doing everything else on the side, because this is what interested me. And my goal one day was to get out of my full-time job and then find my way into blockchain full-time. And that was, which I think is very resemblant of a lot of people's journeys, is how do I go from my current full-time job that I don't like in Web2 or some other world and bring all of my skills into Web3 and actually start getting paid to do what I like to do. Yeah.
Awesome. Thank you so much, Phil. Yeah, guys, Manu?
It's fun because I also had a military background,
Yeah.
mechanical military background,
Cool.
from like long time ago. Yeah, I think I started to mine some ETH in 2017. I have like 17 GPUs in my home.
Oh, 17! Oh my god!
It was my heater. No, in the winter I didn't need any heater. And yeah, it was fun. And yeah, later on I joined a company named Kiln. It's a staking company. Maybe some of you know. And yes, I was managing the Ethereum staking infrastructure. And yeah, and so I saw some bugs in. I was a heavy user of Teku, Lighthouse, and Prism, and other gas and Netherland. And so I saw some bugs. I just submitted some reports, some on GitHub. And yeah, then after I just saw that the EPF program, it was EPF 3, it was 3 years ago, I think. I applied, I worked on Prism, and then after a few months ago, yes, I started to work full time on Prism since 2 years, something like that, or 2 years. Yeah, basically, that's my story entering core dev.
Awesome, thank you, Manu. So Manu is from the EPF 3, from the first cohort we organized with Josh, and like also my T-shirt is from Denver, from our first EPF day actually. So this is the third, fourth one, but yeah, that was the first one we did. Yeah, awesome. And the EPF 5 Dan. So yeah, if you can tell us about your journey.
Yeah. So I'm an engineer. I think I'm some sort of a converted non-believer, because if you ask me maybe 4 or 5 years ago about Bitcoin, I didn't even know what Ethereum is. But I would say no, it's not regulated. So, so yeah, me onboarding on a blockchain, first on app layer, was because I have a company that does engineering in water sector, public water sector, and my company needed a loan, and of course banks said no. It was COVID and stuff like that, and a friend said, hey, look into DeFi, you might find something interesting there regarding nobody asking how do you have the collateral, from where do you have the collateral to get a loan and stuff like that. So in the end, leaving that aside, I ended up in a Reflexor community, the ones that issue Rise stablecoin. I don't know if you guys know it. It's like, in my perspective at least, it's the most decentralized and censorship resistance protocols that are out there. Didn't get traction too much though. So in that community, I learned the value of holding your own keys and holding your own, basically your own coins. And we had an issue with Ryan not accepting staked ETH, just raw ETH, because of security issues. And then there was some discussions with Vitalik, and we looked into what would it take for protocol like write to accept state is, and that got me into to look actually what staking is at the protocol level and if there's something to be done. There's still at this point no stablecoin issuer that would mint stable coins just based on your staking proof. So they're all basically looking towards liquid staking. Then I joined, looking into this, I joined Mario and Josh for the first study group. I never looked back basically after that. I put everything on the side and said, okay, that's it. And the study group was great. We formed a nice group. We initiated a nice knowledge base. And then we moved into the cohort, and yeah. Then I got into EODS. Yeah, again, it's like build it because we need it or something like that. So I'm grateful for the chances I got.
Awesome.
Thank you guys.
Yeah, thank you, Dan. Awesome. Yeah, so yeah, we have Dan from the very latest cohort, also from the study group. Manu from the first cohort, even before the study group, and Phil even before the EPF was a thing. So yeah, different experiences. But I wonder, like, what something that you could share, something that was a revelation for you, or something that you wish you knew at the time you were starting. What is something that you learned, something that you some challenge that you overcame, and you wish you knew it before you had to deal with this? Something that people starting their core development journey should know. I don't want them to, learn it the hard way. So if there is something that you wish you learned the easy way, now you have the chance to give it to them. If anything comes to mind, whoever feels like it, yeah.
I might have one. Okay, so like I think what a lot of people misunderstand is like if there's like some sort of a standard way or like a ladder to or a roadmap to becoming like a core developer or anything like that. In the case of Ethereum, we are like truly decentralized in this matter. Like there is no one path to get to core contribution. A lot of the people that we actually find, either we meet at conferences, we accept their PRs on our repos. People just show up and start contributing. Is really like something that I wish like more people do, because a lot of people do come and be like, oh, how do I become a core dev? And it's like there is no real answer to that. It's kind of like everybody comes from like various worlds, various skill sets and stuff like that, and have something unique that they can contribute to the ecosystem. And it truly is permissionless. Like no one is going to, necessarily say, no, you can't be a core dev. Like that's just not how it works. And if I were to tell you my journey, or somebody else's journey on the Lodestar team, it's very, very different for each of them. And if you guys are looking to find your way into core development, it's very much like a choose your own adventure, but also like, people do notice in the community when you are contributing work. So a lot of the times, like everything is open. So we're able to see the work that you're contributing, the skill sets that you bring, the experiences that you bring, and if it aligns well with what we're trying to do, depending on which project you're looking to join, people will take notice and they'll reach out and see what we can do to help you. Yeah.
Awesome. Yeah, thank you, Phil. That's real nice. Yeah. Hey guys, do you have thoughts?
Yeah. You want to go? Okay. Yeah. Something I learned is, I think writing a client which works 99% of the time is actually quite easy. But if writing a client which works 99.9% of the time, or even 100% of the time, this one is very hard. Because even in the specification or in the implementation, we have to spend a lot of time of energy to think about really not the standard case, but the bad case, not the case you don't want to happen on the Ethereum network, like lack of finality or some nodes which are going rogue, or everything that could happen and that will probably never happen. And so, which is something which is quite interesting is, I think we write a lot of code which will actually normally never be executed. like because in a normal network you don't need to get into this code path, which is only executed if things are going wrong. But as we saw a few weeks ago with Roletsky, maybe you people know. So when we try to upgrade from DNet to Electra, we had a lot of issues, and this really proves that yes, we need really to think about deeply and to implement correctly all these niche case which are only executed if the network is not going so well. Yeah.
Yeah, awesome. I think it's hard to be perfect in theory. Like we strive for perfection, but it's
impossible to be perfect actually. And yes, and you have to admit it, and you have to admit that okay, you can be almost perfect, like 99.9%, and reaching coming from 99.9 to 99.95 will require twice the amount of work. And so you have to say, okay, I will stop here. I hope other clients with client diversity will do 99.9%, but I hope that the 0.1% is not the same than us. And so, if there is an issue, hopefully not all clients will have the same issue at the same time. That's why client diversity is really important. And yes, this client diversity really covers the fact that nobody will have 100% of coverage. There is still some room for bugs, and it should be okay thanks to client diversity.
Yeah, thank you, madam. So, Dan, from a researcher perspective,
I wanted to relate a bit to the EPF, the cohort itself. To paraphrase Tim Baker, EPF is the most institutionalized way to enter into Ethereum. Of course, codes like in codes. So it is one of the governance ways to onboard people on protocols. So of course it's a personal bias here because we had such a good time in EPF 5 that I can only recommend EPF, but it is a good official way to go into Ethereum for you guys. And what I've learned, I cannot say it's not necessarily the hard way, but I didn't know it at the beginning, is that don't expect to be held hands. Yeah? So pick up yourself and put in the work, and results come invariably after. So
yeah, thank you, Dan. Oh, that's very good advice. Awesome. And so before I open it for questions, I have one more to be also a bit more technical, maybe, because recently, especially this year, I feel like it's been most like disruptive what's happening around the protocol. Most focus on making things faster, better, and like picking our governance processes and so on. And it also reflects on the client teams. And I wonder, like, whether there is something specifically that you are excited about, something maybe you are worried about. What are some cool or challenging things that you are dealing with today in your work, in your client or research? Like, how do you feel about upcoming challenges or some cool new features? Or anyone?
I can start again. So as some of the Nimbus guys already mentioned, like Lodestar did do quite a large pivot, you can say. It's very similar to, I guess, the new roadmap, the more clearer roadmap of the Ethereum Foundation as to what they want to be doing at the base layer, which is, to scale L1, scale blobs, and the UX, which you've probably heard of many times now. But this has been like actually the most direction that client teams have gone in quite a while. It's actually like kind of refreshing to hear because there is a direction. Some may not agree, some do, but at least there's a direction. So at least for us at Lodestar, back in 2018 when the project started, there was a lot of interest at the time, thinking that like JavaScript tooling would have been like a really big thing as part of the E2 transition back in those days when we envisioned the beacon chain. But as you can see, a lot of this has sort of pivoted a little bit. You can even see some tooling, like even Ethereum JS, unfortunately not survive the transition with the EF. So there are some things that we are aware of that we are going to try to do to make ourselves much more useful at the base layer, and not necessarily focusing on like a TypeScript based implementation. We're going to actually do what Ethereum needs of us, and which is really to scale blobs on the consensus layer. So for us, one of the most exciting things now is we're going to utilize bun runtime, which is also written in Zig, and which we've seen quite a bit of optimization, even just switching from Node.js to bun runtime, and also rewriting some of our core modules in Zig, because we found that going native on a lot of these things will allow us to basically keep up with the roadmap. If we're going to scale 70 to 72 blobs and higher than that, we need to ensure that like we're capable of doing that. So at least for Lodestar, like we're very excited to actually contribute more to like the Zig Ethereum ecosystem, even though more in the beacon chain side of things. And those are some of the challenges that we've been dealing with on our side, is really ensuring that we can continue to serve Ethereum as well as Lighthouse and Prism and all the other guys are doing, and not fall behind basically. So that's what we're excited about.
Awesome. Yeah, thanks so much. Yeah, that's very exciting. Zig is also like a sort of a new language, exciting new thing. So it's exciting to hear. Awesome.
Yeah.
So yeah, what are you guys excited about or worried about?
Yeah, but well, I'm really excited about this new roadmap of EF. So as you said, scale blob, scale N1. And even on the short term, like EPDS, like FOSI, like Kerdas, of course, which I am working on. But I think the most important step for me is improve UX. I mean, even us, which who are in the Ethereum domain, I think it's still hard when you want to really interact with the Ethereum network. You have to take your ledger or any wallet, and you have to plug it, and okay, I have to put my password. Oh, okay, actually it was too long when I was when I had to do some stuff on the computer, and then I have to pass again. Oh, okay, I forget it. And you submit the transaction. Oh no, before you have to swap to allow for the token swap. And then you can run the transaction, but the gas price increases. So it's really hard even for us to use it. I really feel that Ethereum will win when people will use Ethereum without noticing they actually use it. When you use a computer, when you use a computer, you don't know you are using a Intel CPU with 32 gigabyte of RAM with a Linux core. You don't just use it. It's very very natural. And yes, and I really think that the most important point is this improve UX stuff. And UX is very large, of course. It could be the swap time, because we want the transaction to appear on chain faster and not be rare. And also really basic stuff, not basic stuff, but really standard stuff like the front end of the wallet, like React stuff, should be really improved to onboard next billion users. And it is really exciting. I'm really happy that EF thinks that it is an important thing to do.
Yeah, I agree. I should have been the first place, right?
Yes, I agree. Not the third, the first one.
Yeah, I think it's the third one just because we don't know how to do it yet. But yeah, sorry, that's my comment. Yeah, thanks so much, Manuel. Yeah, that's awesome. Yeah, and Dan, do you have any thoughts?
Like research-wise, or on this perspective, I'm also pretty excited about the roadmap. Basically, reading beam chain roadmap, I understood for myself that it's not going to be a refactorization of the specs or of the clients. I don't think we will have, you guys, maybe you can tell us. I don't think we will have like new clients. I don't think that's going to be the case. It's like more likely we're going to have substantial upgrades up to a point, like having PBS, shortened times, SSF. Actually, that's probably later. And then we're going to go to ZK EVM snarkification of the beacon chain. Yeah, and then SSF. So basically, that's how I perceived it reading the roadmap. So I don't think that we're going to have like a tabula rasa and then rewrite the protocol. So it's the protocol we have now, apply the most important upgrades. So we have shorter slot times, SSF, improve UX. By the way, there's this fast confirmation rule. Do you guys know about it?
Yeah.
They picked it up. Might be something interesting.
Yeah, we have some fellows interested in FCR. Yeah.
Okay. Yeah. And then ZK. I'm not an expert in these things, but for me, having ZK EVM plus snarkification of the beacon chain is like. Yeah. After that, we run the protocol on the smartwatch.
So you actually think that the beam chain will be just yet another fork?
Yes. I don't think so. I saw it in the.
I agree with you actually. When I see.
You agree or disagree?
Agree. But when I see maybe it's not really the topic, but for me, switching from beacon chain to beam chain, it's like switching from fission nuclear power plant to a fusion one. You change the core of the system. I mean, it's totally different. But
it's not a different tech.
But yeah, 90% is the same. I mean, you still need P2P, you still need the beacon
Except
API,
for
you still
ZK,
need
Except for ZK,
you still need I don't know a fork choice, the database, and so the core is changing, but the rest is the same, and that's why I kind of agree that beam chain could be just yet another fork.
And I think it will.
Yeah, I see the contributions people are making to Beam right now is very much like trying to pave a way for us to basically transition to. So, it's great that they have the ability to do a lot of the experimental things like 3-slot finality and stuff like this, where they can actually test out these futuristic theories and implement them. Because client teams that are maintaining the beacon chain, we have like no resources to necessarily contribute to that. Like we're still figuring out pure DAS right now. So it's like, the way that I see it, it's kind of like, very much like a parallel stream happening. But eventually, like the stuff that the beam chain clients will figure out for our future, eventually will just downstream help us, give us like a bit of a guiding light as to where we're going. That's
If
how
I may ask, are there going to be beam chain clients, or it's you guys going to upgrade to that?
It's hard to say at this point, because at the end of the day, like you said, like 90% of it is basically stuff that we already have, and we just need to do like a few tweaks here and there to get us from a beacon chain state to a beam chain state.
I mean, there are big Beam clients right now. We have a couple of contributors here, but they are just re-implementing the beacon chain. They're just re-implementing the features, but but there is no spec yet. So what I'm worried about is that maybe you could know more about it. Like that we will have to we will repeat the same mistakes like with a beacon chain when like Prism, for example, was the first client. But the specs were changing, and like 2018, 19, the beginning of the Prism is different than 2021 actual beacon chain Prism, right? So I'm worried about bit about the beam chain and these bunch of these contributions right now. I think they are useful for prototyping, but it will look vastly different in a couple of years or so. Cool. We get to the technical discussion as well, but we have still a couple of minutes. Questions, comments, thoughts. For all of them, or individually, if you have any questions about being a core dev, something that we discussed about your journey, or technical questions about anything goes.
Hi. I have a question about Zig. Actually, I briefly checked their language description before. It looks pretty like the C. And I'm wondering how you're feeling about using that compared to C and other languages, and especially for like large project and also like with like P2P network stuff.
Oh, that's a really good question. We're really just like touching the surface right now, and I don't have as much experience with that, so I wouldn't be able to give you an answer to that question, unfortunately. But yeah, like there are 2 guys on our team right now that are focused on our Lodestar V2 right now, and they're the ones that are really digging deep into Zig. And yeah, sorry, I wish I could provide you with more information.
No. I mean, I'm a big fan of C, and but I find like for develop a large project, it looks like pretty hard sometimes.
Yeah, it is like very like leading edge stuff. So we are like aware of just like perhaps like the unknowns, I guess, that we might run into. Like even something like the bun runtime is still like, I don't know if it's really been used in a large scale project in production yet, right? So it's very much like, it's very exploratory, and we are aware of it. Like there's ongoing debates about where we, continue maintaining and supporting Node.js, maybe even Dino, we'll see. There's a lot of ongoing discussion right now for sure about that.
Pioneering, I mean, that's great.
Yeah.
You're trailblazing, right? So yeah.
Yeah, trailblazing. Like we are definitely pushing TypeScript to its limits already, and you've already seen like we can only go so far with it.
Yeah.
So yeah.
And just I saw Microsoft wanted to rewrite TypeScript in Go actually.
Yeah, there's like a Go compiler now.
Yeah.
They did, yeah.
I told you
Yeah, we needed that like years ago.
Okay. I mean, it's too late.
It's too late.
Yeah, it's sort of compiler, right? Yeah, folks. Any more questions? We have a bunch of cool people here. You can ask anything. You can get advice. Yeah.
Yeah, so we often talk about how like there has been 100% uptime on Ethereum, and you being called that, so you develop the clients, right? So, but unlike like traditional logs where you run the infra and everything, like at 2 a.m. you have calls, so something must have gone like at once when at 2 a.m. and your colleague calls, yeah, she did the fan, get up. So how common is that, and how is that dealt with at the core level? Because if there is a critical bug, you cannot just change Ethereum overnight.
Yeah, incident response.
Yeah. So I don't really agree that there is 100% uptime on the Ethereum, because
there is.
No, I mean if we miss a block,
Availability.
if you miss a block,
if
you miss a block, it's like 12 seconds of downtime. I mean, that's and you can miss a lot of blocks now. But yes, we had 100% of time or of uptime where at least 1 block per minute was published, and almost 100% of time of finality on mainnet. But your question, yeah. So I can speak as a core developer and node operator, because before I was node operator, and yes, I was sometimes page at 2 in the morning. Honestly, it was more for Solana. Solana will wake me up quite often at the night. It's around now. Yeah, actually, it was quite. If you, for example, if a client has an issue and you are a node operator, you can switch client. I mean, if there is an issue with Prism, you switch to Teku or to Lighthouse or any other one. And normally it should solve. I mean, if the issue is not at the exact same area for several clients. And yes, and as a core developer, if you have an issue with your clients, so it's quite embarrassing. But yes, I mean, you don't need to wake up at 2 at night, because it won't change anything. You wake up at 2 at night, you fix the bug, and people won't upgrade their node normally before a few hours. So you wake up if you want, you figure out what is going wrong, you fix it, and you publish a patch, and you say, oh, people, please, please upgrade. And thanks to the client diversity, actually, we can have this chill window of bug fix because thanks to client diversity. Yeah. Which is not the case of Solana, for example. That's why it was important when we had a bug in Solana to fix immediately and to upgrade immediately.
Yeah. Basically, like just quickly adding to that, I mean, as long as we try to keep our largest client share under 33%, we can at least prevent non-finality if there is like a consensus or a bug on a specific client. Yeah. So a lot of the times we'll pick up each other's slack, but we need node operators to actually be running multi-client setups to be able to benefit from this. Like one of the things that we saw on Holsky was that a lot of people weren't running Greth and Aragon nodes, as an example, and that created a huge problem because they were the only ones on the correct minority chain at the time. And then when you have that happening, if very few people are running these nodes, it's really difficult for you to get synced onto the correct chain when there's already so few. You're basically like DDoSing the healthy ones. And then once they fall out, like syncing is a terrible nightmare when you have a situation where the chain is just not happy with like it's just confused most of the time.
One few minutes ago, I talked about working on code which is almost never used. I was specifically thinking about syncing in difficult conditions. It's really hard because, and especially with sharding, because you don't know which peer is on the good chain, and if it is on the good chain, maybe the peer has not the data you need. And yes, and syncing in difficult conditions in unfinity is yes, very difficult task.
Yeah. Another shout out to anybody who's like really good with like testing. Like we need a lot of people testing our clients in very terrible conditions. Like that actually helps quite a bit. And we generally don't have time to test anything outside of the happy cases. So like more like hats off to the Pandops guys and stuff. Like we need a lot of that.
I think the Holschk incident teaches a lot. Like we learned a lot there because there never been such a situation, and like during the whole beacon chain and mainnet, like never experienced such a thing. But actually now the incident response is improved as well. Like the process that we have now around hard forks, there are dedicated people from client teams who should be like on call in the given time zone when the fork is happening. And then Sepolia was also had issues, and we were at an event with EF with PandaOps, and it was like a couple of minutes after the fork, and suddenly all of the PandaOps and the Get team just stands up, right? And we cool. Well, let's do one more questions. We have time for one more maybe. If there is anything you would like to ask, let's wrap it up somehow. Anybody? Yeah? Josh?
Will Ethereum need core devs forever?
I think devs, the dev job will change a lot. I'm specifically thinking about LLMs and Cloud Code. We use more and more Cloud Code. Ethereum will always need, I guess, people able to think about how the protocol should work, to write the spec, or not only the spec, but really to think about the architecture of the Ethereum, and so yes, writing the spec. And maybe LLMs will convert the spec into code. But for sure, we will still need people able to code review, to do code review, and to be sure that there is nothing which is missing. Because writing the code is not really the interesting part. Interesting part is thinking about the design and be sure that you have a very good design and very good coverage for all the small edge cases that LLM may miss.
I think there will always be some core devs, whether or not you need as many in the future. That depends, I guess, on if we're happy with ossification at some point. But just looking at it right now, it doesn't seem like it. So very much like I feel like we're gonna need core devs in the near medium term future at the very least. Like we just don't have enough people, I think, especially in the implementation side, to like do what we want to do. I feel like. But yeah, it's hard to say like what's after like quantum computing. Like we might still need to
Maintenance.
Maintainers.
That's after ossification, you get maintenance forever.
And well, if you want to keep client diversity, you need maintenance of each client, right? So it's still a lot of people.
And there always will be some small upgrades or some I guess, some breakthroughs in technology.
Softwares, maybe.
Yeah. If we keep progressing, we hope that Ethereum would progress with it.
Yeah.
Because even Bitcoin at some point is going to have to upgrade its cryptography. So
But I like the sci-fi idea that like we scale Ethereum that much that we run AI on Ethereum that's repairing itself, right? Self-replication.
And then you need the AI diversity.
Okay. I think we can wrap it up here. Okay, thank you, all of you. And Dan, Manu, Phil, thank you so much. It was great, and we'll see you for dinner. So, what time? 7? 7 p.m.